Hello and welcome to another video brought to you by RouTube. In this video, I will explore adding and subtracting fractions, as well as go through a few basic things to do with fractions. Students are introduced to fractions in upper primary school and will continue to develop their knowledge in junior secondary school. So there's a few learning objectives in this video. The first one is to recall some prior knowledge regarding fractions and their properties. The second learning objective is to be able to add and subtract proper fractions by finding what we call the lowest common denominator, which we use LCD. And the third and final objective is to be able to convert mixed numbers to improper fractions and then either add or subtract them. Okay, so before we get into adding and subtracting fractions, I thought the best place to start would just be to recall some prior knowledge. So depending on what year level you're in, you might be pretty confident with the main properties of a fraction, but like I said, I thought that's the best place to start. So what are fractions? So fractions are used to represent parts of a whole. Okay, we have a few different parts to a fraction. The first part is what we call the numerator, which is the top number of the fraction, and it shows how many parts are required. Now this value must always be an integer. Okay, an integer is a whole number, whether it's positive or negative. And for today's video, they're all just going to be positive. Second part of a fraction is what we have as the denominator, which is the bottom number, which shows the number of parts into which the whole can be divided into. Okay, this value must always be an integer as well, but it cannot be 0. Okay, and for today, once again, that will always be a positive integer, the denominator. So the horizontal bar separating the numerator and the denominator, which we can clearly see in red, is what we call the vinculum. Okay, now we don't often, it's not something that we really place a high level of importance on, but you know, it's important to know some random things about maths sometimes, and that's definitely one random thing. So that middle line in a fraction is what we call the vinculum. A proper fraction, this is one that most people are probably more familiar with. So a proper fraction has a numerator that is smaller than the denominator. So for example, we have 1/4 or 1/3 or 1/2 or 1/5. Okay, there's plenty of them out there, and plenty of them I'm sure you have seen before. An improper fraction has a numerator that is larger than the denominator. For example, we have 4/3 or 5/2 or 6/4 or anything where the numerator is greater or larger than the denominator. And finally, we have what's called a mixed number. A mixed number is made up of a number and a fraction. So it's made up of a whole number and a fraction. For example, as we can see there, 1 1/3, or it could be 2 4/5, or it can be 3 8/10. If it's made up of a whole number and a fraction, then we refer to it as a mixed number. All right, let's now turn our attention to actually adding and subtracting fractions. So fractions can be added and subtracted if they have the same denominator. That is super important to understand. Okay, if you sort of can't remember that, or you sort of forget it, then adding and subtractions essentially becomes impossible for you to do. So you can only add and subtract fractions if they have the same denominator. When fractions have the same denominator, they can be added together by adding the numerators and subtracted by subtracting the numerators. Now, there's a reason why I've bolded the next sentence, because it's such a common error that occurs, and often some students sort of apply it when they shouldn't. Okay, so when we're adding and subtracting fractions, as we've just spoken about, we need to add the numerators or subtract the numerators, depending on if it's an addition or a subtraction question, but we need to make sure we do not ever add or subtract the denominators. Okay, we only add or subtract the numerators, not the denominators. If the denominators are different, what we need to do is we need to make what's called equivalent fractions by finding the lowest common denominator, which we'll have a fair bit of practice at in this video. So the lowest common denominator, which we use LCD to represent the lowest common denominator, or to denote it, to write it in that way. The lowest common denominator is the smallest multiple of all the denominators in a set of fractions. Okay, so you might be asked to add 2 fractions together, or 3 fractions, or 4 fractions. Okay, we'll start quite simple today in this video. So what you need to do is you always need to find the smallest multiple of all the denominators in the number of fractions that you're given. And the last and final thing in this part is to always remember to simplify the fraction if possible. Please don't wait to be asked to simplify, always simplify. All right, so let's actually have a go at adding and subtracting some fractions. So the first question says, question A says, find 1/5 plus 2/5. So as we know, we can only add or subtract fractions if they have the same denominator. So in this case, question A, we do have the same denominator. So the denominators are both 5. So therefore, we can simply just add the numerators together. So what we do here, I'm just going to write out the question again. So we've got 1/5 plus 2/5. Okay. What we do, we just add the numerators. So 1 plus 2 should hopefully give us 3. And remember, as I said in bold before, we don't add the denominator. We just leave the denominator as it is. And therefore, I'll just highlight our answer. Our answer should be 3/5. So there's our final answer. The only thing we needed to do was add the numerator and keep the denominator the same. Moving on to question B, it says find 9/10, subtract 2/10. So once again, I'll just write the question. So 9/10 minus 2/10. Are the denominators the same? Yes, they are. So once again, we leave the denominator as it is. So we know it's going to be tenths. And we just subtract the numerators. Okay, so 9 minus 2 should give us 7. Now, it's really important that we need to simplify whenever we can. And in the first example, 3/5, there's no number that goes into both 3 and 5. And the same way, there's no number that goes into both 7 and 10 other than 1. So therefore, we cannot simplify either of these answers anymore. But we will have a go where we will have to simplify further. But for now, we're just stopping there. So that final answer should be 7/10 or 7/10. Question C says find 12/12 minus 1/12. Okay, so 12/12, some of you might already know, 12/12 or any number over the same number is just equal to 1. Okay, so 12/12 is another way of just writing 1. Okay, so let's write the question. So we've got 12/12 minus 1/12. Once again, are the denominators the same? Yes, they are. They're both 12. So we just subtract the numerators. So therefore, 12 minus 1 will give us 11. And we keep the denominator the same. So therefore, it becomes 11/12. And we know we're finished. And that's our final answer because there is no value or no number that goes into both 11 and 12 to simplify other than 1. Now moving on to question D, now we have a couple of different steps that we have here, okay? But please don't be alarmed because it's not too much difficult than the previous ones that we have sort of done in A, B, and C. So here we have 5/8 minus 1/8 plus 3/8. So once again, I'll just write it out. So we've got 5/8 minus 1/8 plus 3/8. Okay, now remember, we need to check, first of all, are the denominators the same? They need to be the same for all of the fractions. Okay, so we've got 3 fractions here, and the denominators are all the same, which is fantastic. Okay, so that means our denominator of our answer is going to be something over 8. Okay, we don't know what the numerator is. We're going to do that in a second, but the denominator is definitely going to be 8. Remember, we don't change the denominator. So then now we just need to add and subtract the numerators. So the first numerator is 5 and the second numerator is 1. And there's a subtraction sign in between. So therefore it's 5 minus 1, which gives us 4. And then we need to add 3 to that number. So it becomes 5 minus 1 is 4. And then 4 plus 3 gives us 7. So therefore 7/8. Now, is there another number other than 1 that can go into both 7 and 8? And the answer is no. So therefore we cannot simplify this fraction any further. And we'll finish off this part by having a look at this question here. So we have 39 hundredths plus 8 hundredths minus 10 hundredths. All right, so once again, we'll just write out the question. So 39 over 100 plus 8 over 100 minus 10 over 100. Okay, so once again, the denominators are the same, so therefore we know our answer is going to be something over 100. Okay, so we do the same thing we did previously, we just add and subtract the numerators. Okay, so you might need a calculator for this, If you do, that's totally fine. Okay, but we need to add and subtract the numerator. So 39 plus 8 should give us 47. And then 47 minus the third numerator, which is 10. So 47 minus 10 should give us 37. And again, is there a common factor other than 1 that goes into both 37 and 100? The answer is no. So therefore, there's our final answer. So that's having a go at adding and subtracting fractions with the same denominator. It's really important that you don't change the value of the denominator. You only change the value of the numerator, whether you're adding or subtracting. All right, let's have a go at a few more adding and subtracting fractions examples. So this one says, find the following expressing the answers in simplest form. So let's have a look at our first question. Our first question is 5/12 plus 3/12. Now, once again, same denominator, so should be fairly straightforward to add these two fractions together. So we've got, let's write it out again. So 5/12 plus 3/12. And I might work down the page just so we've got enough room. Same denominators, so we know our answer is going to be over 12. We're not changing the denominator, same as the previous few questions. And then we're just going to add the numerators to give us 8/12. 5 plus 3 gives us 8. Now, if you wrote 8/12, I would give you half a mark. Okay, and the reason is because we have not fully answered the question, which is to express the answer in simplest form. So to express the answer in simplest form, we need to find what's called the HCF, the highest common factor between the two values, between the numerator and the denominator. So you need to ask yourself, what is the highest value that goes into both 8 and 12? So essentially, what's the highest factor that is common with 8 and 12? And hopefully you can identify that that value should be 4. 2 is common with 8 and 12, but 4 is a higher one. So always go with the higher one. Okay, so what we need to do is we need to then divide by the highest common factor, which is 4. So we divide both the numerator and the denominator by 4. Remember the golden rule for a fraction, what you do to the top, you must do to the bottom. And then we have, on the numerator, we have 8 divided by 4 should give us 2. And then 12 divided by 4 should give us 3. So there's our answer completed and simplified fully. Now, if we got that answer, then you will receive full marks. Moving on to question B. So we need to subtract, we've got 9/4 minus 7/4. This one looks a bit funny because they are both improper fractions, but we still follow the same process. So once again, write down the question. So we've got 9/4 or 9/4 minus 7/4 or 7/4. So once again, we'll work down the page so we have enough room. Again, we know it's going to be out of or over 4. The denominator is not going to change. The only thing we're going to do is now we're going to subtract the numerator. So the same process gets quite repetitive as we go on. Okay, so 9 minus 7 should give us 2. Once again, if you finish there, I'll once again give you a half mark, okay, because we have not simplified fully. So once again, what is the highest common factor? What value other than 1 goes into both 2 and 4? Well, hopefully you can see that it is 2. So therefore, we need to divide both values by 2. Remember, what you do to the top, you must do to the bottom. And therefore, on the numerator, we have 2 divided by 2, or 2 has how many 2's, which should be 1. And then 4 divided by 2 should be 2. So therefore, the answer should be 1/2, which is just 1/2. And then finishing off this part, we move to question C. So we've now got 11/28, 11/28 plus 10/28 or 10/28. Once again, same process that we have been following, 11/28 plus 10/28. Okay, and again, work down the page. We know our answer is going to be something over 28. We're not going to change the denominator once again. And now we add the numerators because there is an addition sign. So 11 plus 10 should give us 21. Now this one here, if you're not so confident with your division and multiplication skills, you might finish here. But once again, if you finish here and that you sort of say that that's your final answer, you once again receive a half mark because you have not simplified correctly or enough. Okay, so what we need to do is we need to find a highest common factor, or the highest common factor between the numerator and the denominator, which are 21 and 28. So what number goes into both 21 and 28? Hopefully you can identify that that is 7. Okay, so 7 goes into both 21 and 28. So we divide both the numerator and the denominator by 7. And therefore, we do the numerator first. So 21 divided by 7, or 21 has how many 7s? Should be 3. And then 28 has how many 7s? Well, it's got one more, which is 3 over 4. So therefore, our final answer should be 3 over 4, which is 3/4. All right, now let's have a look at adding and subtracting fractions by finding the lowest common denominator, LCD. So answer the following questions by first finding the lowest common denominator. And then, as always, we need to simplify our answer if it's necessary. So the first one we have is we've got 1/2 plus 1/3. So I'm just going to write that down. So we've got 1/2 plus 1 over 3. Now, clearly we don't have the same denominator, so we can't just add or subtract them. Remember, we can only add and subtract fractions if they have the same denominator. That's the first thing we read in this video. So it's really important to remember that. So we need to find the lowest common denominator. And what we need to do, that's essentially the lowest common multiple between the two denominators. So what we do is, let's just list the first few multiples of 2 and the first few multiples of 3. So essentially you're counting by 2s and counting by 3s. So it goes 2, 4, 6, 8, 10. Let's just stop there and see if we find anything that's common with both of those numbers. So then we count by 3s. Then we go 3, 6, 9, 12, and 15. Now, is there a value that's common with both? Well, clearly there is. And the lowest one is 6. So therefore, 6 is going to be our lowest common denominator between those two fractions. Okay, so what we need to ask ourselves is, we need to say, what do we need to do to the denominators to get them to 6? What do we need to multiply 2 by to get to 6? We need to multiply it by 3. And that means whatever we do to the top of the fraction, we know we need to do to the bottom of the fraction, and vice versa. So we need to multiply that also by 3. Now, what do we need to do to the second fraction to get the denominator to be 6? So what do I need to multiply 3 by to get to 6? Well, we need to multiply that by 2, which means we need to multiply that by 2. Okay, now we've got a fairly complex, a few stuff written down, so let's just simplify it a little bit. Okay, so we rewrite our first fraction as 1 times 3, which is 3, and then we have 2 times 3, which is 6. And then our second fraction is 1 times 2, which is 2, and then 3 times 2, which is 6. We're much happier now because we have the same denominator, and we can simply just do what we've done previously, which is to leave the denominator the same and then just add or subtract. In this case, we're going to add, just add the numerator. So it's going to be, or the numerators together. So it's going to be 5 over 6. Now, is there a value that goes into both 5 and 6 that's not 1? Well, no, there is not. So therefore, that means 5/6 is the final answer. Next one, we have 7/10 plus 2/15. So clearly, we do not have the same denominator in both fractions. So therefore, we need to find the LCD. So as we did before, let's list the first few multiples of each value. So we've got 10 and 15. So we count by 10s, goes 10, 20, 30, 40, and 50. And the next one goes 15, 30. Well, we've already seen we've got one, which is great, and 60. Okay, so we've already got 30, which is the lowest common denominator, or lowest common multiple between the two denominators. So then now we ask ourselves, what do we need to multiply both of the denominators by to get to 30? So we have 10. So what do I need to multiply 10 by to get to 30? Well, we need to multiply by 3, which means we need to multiply the top of the fraction by 3. Remember, what you do to the top, you have to do to the bottom. And what you do to the bottom, you have to do to the top. And then now we move to the second fraction. What do we need to multiply 15 by to give me 30? we need to multiply 15 by 2, which means we need to multiply that by 2 also. So remember, what you do to the top, you must do to the bottom. That's the most important thing that I want you to take away from this part. Then, now, let's rewrite our fraction. So we've got 7 times 3, which is 21. And then 10 times 3, we know it's going to be 30. Plus 2 times 2, which is 4. And then 15 times 2, which is 30. Okay, once again, we are now very happy. We have the same denominator. We can now just add the numerators. So we've now got 25 over, oops, I was going to make an error there. So 25 over 30. Now, if you finish there, once again, I'll give you a half mark. Okay, we're almost at the final answer, but we're not quite there because there is still a number that goes into both the numerator and the denominator. That goes into both 25 and 30. Okay, and that value is 5. So 5 goes into both 25 and 30, which means we can simplify both of those values by 5. So then now we have 25 divided by 5 gives us 5, and then 30 divided by 5 gives us 6. So therefore, the final answer to that question there was sort of a couple of steps there because we needed to simplify at the end, should be 5 over 6, which is the same as part A. And the third and final question for this little part here is 6 over 11 minus 1 over 3. Okay, so once again, we know that we cannot simply just subtract because we have different denominators. So let's list the first few of 11. So we go 11, 22, 33. Now 3, this one might be a little bit more difficult because you might have to list a few more multiples of 3. Okay, but essentially what you need to see is, does 3 go into the first multiple of 11, 11? No. Does it go into 22? No. Does 3 go into 33? Yes, it does. Okay, so that means 33 is going to be the lowest common multiple, the lowest common denominator between the two values. So that means, what do I need to multiply 11 by to get to 33? Well, we need to multiply by 3, which means we need to multiply the 6 also by 3. And what do we need to multiply the 3 by to get to 33? Well, we're just doing a reverse of the previous fraction. So it's going to be 11, which therefore makes 11 there. And now we can rewrite our question. So we've now got 6 multiplied by 3 gives us 18 over 33 minus 1 times 11 gives us 11 over 33. Now we're happy. Once again, same denominator. We can just subtract the numerators. So we've now got 18 minus 11 should give us 7. And therefore, are we finished? Well, yes, we are, because there is no value other than 1 that goes into both 7 and 33. So therefore, the final answer to that question should be 7 over 33. All right, let's now move on to our last part of this video, which is to add and subtract mixed numbers. So as stated at the start of the video, a mixed number contains a whole number part and a fraction. So when adding and subtracting mixed numbers, these two steps need to be taken. Okay, so the first step is to convert them into improper fractions by multiplying the whole number with the denominator, then adding the numerator. All right, so let's have a look at this example here. So the example is convert 1 2/3 to an improper fraction. So I'm just going to write it down here. So we've got 1 2/3. So it says convert them by multiplying the whole number with the denominator. So the whole number is 1, so we're going to multiply the 1 and the 3, and then we're going to add the 2 at the end. So 1 2/3 becomes 1 times 3, which is 3, plus the 2, which becomes 5. So 5 becomes our new numerator, and the 3 stays as it is. So the 3 on the proper fraction stays as it is, the denominator, whereas the numerator now becomes 5, because we multiplied the whole number with the denominator and then we added the numerator. So that's how we convert the mixed number into an improper fraction. And then the second step, once we have that, is we just solve as per normal through addition or subtraction. So we either add or subtract if they have the same denominator, or if they don't have the same denominator, use the examples that we went through previously to locate the LCD, and then we can add or subtract. All right, and let's finish off the video by having a look at a few examples where we need to add and subtract mixed numbers. Well, in this case, it's just two subtraction questions. So the question says, calculate the following, expressing your answer as a mixed number. So both of our answers should be a mixed number. So just like many things in maths, there's multiple ways in which you can do things to get to the final answer. Now, I know a really common way of dealing with a question like this is to deal with the whole numbers first and then deal with the fractions. I personally don't do it that way, but if you do it that way, that's totally fine. So yeah, we're going to go with a different approach in these two examples here. So here we have 4 1/5 minus 2 3/5. So what we need to do is we need to first of all write the question down. So we're going to have 4 1/5 minus 2 3/5. So like I said before, some people, what they might do is they might deal with the whole number. So they might do 4 minus 2 and then 1/5 minus 3/5. Okay, I personally don't prefer to do it that way, but like I said, if you want to do it that way, go for it. So what I like to do is, first of all, convert the mixed numbers into improper fractions like we spoke about previously. So we're going to follow the same process. So multiply and add, and then multiply and add. So our new question becomes 4 times 5, which becomes 20, and then we add the numerator, which becomes 21, and then we keep the denominator as the same. And then now we do the same thing for the second fraction. So we now have 2 times 5, so the whole number multiplied by the denominator, which gives us 10, and then we add the numerator, which gives us 13. So then we have 13 over 5. Now we'll just pop some equal signs here for our working. And then now we have the same denominator, which is great. So then we can just subtract as per normal. So then we've got 21 minus 13. We know it's going to be over 5. So 21 minus 13 gives us 8. But we have not answered the question accordingly because our answer is not expressed as a mixed number. That is what is, that is an improper fraction. So we need to convert the improper fraction to a mixed number. So essentially what we need to do is we need to say, well, how many times does our denominator go into our numerator? So how many times does 5 go into 8 without going over? Well, it goes into 8 one time, and there's 3 remainder or 3 left over. So therefore it becomes 3, and then our denominator once again stays the same. So our final answer to that question is 1 3/5. And then now let's turn our attention to part B. So we've now got 6, and we'll write it again. So 6 7/8 minus 4 3/8. So now once again, you can deal with the whole numbers and then the fractions, which might actually work a little bit easier for a question like this, but we're going to follow the same process as we did for part A. So we're going to multiply and add, and then multiply and add. Same process as we did before. So we've now got 6 times 8, which gives us 48, and then 48 plus the numerator of 7 gives us 55. And then again, our denominator stays the same, which is 8. And then we know our denominator is going to be 8. And then we've got 4 times, so the whole number multiplied by the denominator, 4 times 8 gives us 32. And then 32 plus 3, which is the numerator, gives us 35. And then we've now got the same denominator, which is great. So we know the answer is going to be over 8. And then we can just do 55 minus 35 should give us 20. Now, once again, like previously, we have an improper fraction. We do not have a mixed number. So we follow the same process. And we say, how many times does our denominator go into our numerator? Well, our denominator 8 goes into 20. So we count by 8s until we get to a number without going over. So 8, 16, 24. All right, so 24 is clearly too big. So there's going to be 2 wholes. And then there's going to be 4 remainder, or 4 left over. Okay, and the denominator is going to stay the same. So 2 and 4/8. Now, if you get that, I'll give you, once again, I'll give you half a mark. Okay, and the reason is because, like we said previously, You must simplify your fractions all the time. Okay, so our whole number is going to stay as 2, but then 4 over 8, there's a common factor of 4, which means we can divide both the numerator and the denominator by 4, which therefore has our fraction part as 2.5. So our final answer to that question should be 2.1/2, or 2.5. Thanks once again for tuning into another RouTube video. Hopefully you learned a thing or two about fractions, their properties, adding and subtracting, lowest common denominator, mixed numbers, conversion, equivalent fractions, plenty of stuff going on in this video. So as always, if you liked it or you learned something, please feel free to like the video, subscribe to my channel, and I'll catch you next video.